All right, good evening, everyone. Hello. Welcome to Kopernik Observatory and Science Center. We're so happy to have you this evening. Did everyone get to go out and observe Jupiter? Still showed up out there? Okay, that's good. Right off the top here, I am going to take a look at our clear sky chart on our website. That's something I always like to do at the start of our presentations so that we can see after the program, maybe if it stays clear, you might see some stuff. So that's right at the bottom of our website, and you're looking mostly at cloud cover, but you can look at the other characteristics as well. What we want to see is a dark blue, ideally, but even if we get a light blue, we'll take it in Binghamton. So yeah, around 6 p.m. it was looking all right. Now we're now we're after 8 p.m. and it's getting lighter blue as the night goes on. So maybe in an hour, it might hang on. We'll see. There's also these characteristics here, transparency and seeing, which have to do with sky clarity. Even if there aren't clouds above you, there can be other things in the atmosphere. There can be more water in the atmosphere, which would destabilize an image. Perhaps the atmosphere is turbulent. That means the air in the atmosphere is moving a lot. That would also disturb images through telescopes. So those are sky quality measurements. And those aren't terrific tonight. For comparison, if you go look at Sunday night, that's pretty good. Good little cloud cover. Transparency and seeing are above average, I would say, for our area. So Sunday night will be nice. But yeah, you can always refer to this if you're ever wondering if the sky is going to be clear at Kopernik. We try to post clear sky alerts as well on our social media, so you can view, you can follow us there too, so we can update you. Okay, so back to our website. Today's program starts our march to the eclipse here on March 1st, and this is an introductory presentation to kind of set the scene for the eclipse event, give you all the basic information for how to prepare for April 8th and to also safely observe the eclipse. If you want to take a look at our upcoming March to the Eclipse programs, you can go to our website on the March to the Eclipse tab, and it gives you a countdown to the April 8th eclipse. And you can scroll through the event schedule. This is today's event. We also have 2 Family Fridays scheduled, which are going to be less presentation and more activities. So families can come up and collect resources, actually make resources for the day of the eclipse. So you can choose, it's the same program, and you can choose either March 8th or March 22nd, and those start at 6 p.m. We'll also have the planetarium going with our solar eclipse show, which is available tonight after the program as well if you wanted to try that out. We do have just a slight premium to admission for it. It's $2 to get into the planetarium, but you're welcome to give that a go. All right, and then also Friday, March 15th is the Great Adirondack Eclipse, and that's presented by the president of the Adirondack Sky Center and Observatory, Seth McGowan. Did I get that last name right, Art? Yeah. McGowan, okay. So that's going to be an interesting perspective on the total eclipse that will be happening through the Adirondacks. So that's just one location that you could potentially go to access totality, because spoiler alert, we do not get totality here, which we'll find out in the show. Now on March 29th is the eclipse among spring skies. So that's going to be the eclipse in context of what else is out there, because when the total eclipse hits, there will actually be other things to see in the sky, not just the sun and moon and the interaction at play there, but also other things around it, planets, maybe some stars. So that'll put some context to that, in addition to what you can see in the night sky this spring. And then finally, April 5th is the total solar eclipse outlook, which at that point we should have a clear idea of what the weather will look like across our region. We'll take a look at that. We'll talk about some final preparations you can make, whether you're accessing totality or you're going to a partial eclipse. And then on April 8th, the big day, we have 2 observing sessions. We have the one here at Kopernik. If you're not able to get to totality, Kopernik's telescopes will be open, and you will be able to look at the partial solar eclipse here from 1 to 5 p.m. So that's available. And then also we'll have an observing live stream for totality. We actually have an eclipse science team here at Kopernik. A few SUNY Broome students that will be collecting data on totality, and I will be along with them as well, and I'll have a separate rig set up to send totality back home on YouTube, so if anyone wants to check that out if you're not able to travel there yourself. So those are 2 options there. And kind of on that note, jumping off that point, we are streaming tonight's program live, so hello to the YouTube live stream as well. You can just find our YouTube channel at Kopernik Observatory. And we stream these programs, we have observing sessions, there's lots to access there. And last thing on the whole, I guess my promotion talk, and under the support tab, there's a section called Become a Member. If you're not a Kopernik member already, you may want to consider it, because not only do you get free admission to our Friday night programs like tonight, you also get access to the ASTC initiative, which is hundreds of museums and science centers across the states, and there are even some international ones as well, that usually their admission is free under a Kopernik membership as well. A great example of this is the Intrepid Museum in New York City, where one of the space shuttles is. So you could look at that list of participating museums and science center and see what a Kopernik membership can do for you if you'd like to travel to a lot of places. And there's a whole bunch of other tiers and benefits there, discounts at our gift shop, discounts on summer camps and classes at Kopernik, so lots of things to check out there. Okay, with that said though, we're gonna chat about the eclipse tonight. And we're gonna jump into this slideshow here. So yeah, my name is Cartie. I am a science educator here at Kopernik Observatory. And our educators over the last few months have come together and tried to lay out a plan for delivering information about the eclipse, so everyone's as prepared as possible in our community. Not only are we doing these public events, but we're also coming to schools in the area, a lot of school districts. So for the kids in the audience, maybe you'll see us at your school as well, depending on where you are. So we're doing assemblies at a lot of schools, and some planetariums our planetarium is going to some libraries with our eclipse program. We're trying to spread our reach so that everyone's informed about where you can see totality, where you can't, how to view it safely. And this presentation is kind of an assembly of all of that work that we've started and done. So eclipse science and safety, that's setting the scene. We're talking 2 main things here. And you see in our image as well, in the foreground, you do see a type of eclipse. You see the moon here and the sun here. And then in the background, you see another type of solar eclipse. And we're going to focus in on the differences between those 2 images. And that types will be a big part of our talk here as well. So that's just to explain that picture a little bit. As cool as that view would be, this is more just a fun combination of events. This would not exist because both of those are solar eclipses. All right, so what we're discussing, we're talking what is an eclipse? We're going to answer that question pretty quickly right away. What types of eclipses are there? We'll talk about the eclipse at scale. How big are these bodies compared to each other, Earth, Sun, and Moon? And how far away are they from each other? And we'll try and model that. Then we have the solar eclipse at Kopernik and beyond. So we'll narrow in on what does the eclipse look like here, and we'll explore some other areas as well, especially at locations of totality. As we wrap up the show, this will be a case of last but certainly not least, solar eclipse safety. This is paramount when trying to enjoy this event. Biggest thing is you have to protect your eyes during it. So we'll talk more about that. And then we'll also touch on a little basic solar eclipse photography and some things you'll want to think about on that day and maybe how to prepare. Okay, so what is an eclipse? And just double check, yeah, we'll use this. This is actually a video we took this past week from one of our newer telescopes. And if anyone's curious to see it, it is, I think, still set up in the computer lab at the moment. It's just a little tabletop telescope, but it does great work. It's called a C-Star, or C-Star S50 is its full name. And it's designed for what's called electronically assisted astronomy. So it's a really baseline, easy-to-use telescope that you just control over an application. And it turns out it's a fantastic solar telescope. It comes with a filter, and you just tell it where to go. Find the sun, and it finds it for you, no trouble at all. And so this was the sun on Tuesday. And one of the coolest features of the sun that day is this grouping of sunspots here, primarily this one. This sunspot was so big that you could see it with a pair of solar glasses, which we will certainly talk about more later. But it goes to show that if you've heard about these solar eclipse glasses, they're not just for the eclipse. You can, on a regular sunny day, you can see features like this with these on and just your eyes. So that's a sunspot, a very stormy region on the sun, and it's several times larger than Earth. As we start to think about the eclipse at scale and all these, how big these bodies are, this little speck right here is really more about the size of Earth. So that's what gives you a point of comparison there. What's great about this eclipse too that's coming up is that it just happens to be falling along the solar maximum when the sun is very active. You'll see a lot of these sunspots. It's putting off a lot of solar flares and solar radiation, solar wind. So that means that on the day of the eclipse, like here at Kopernik when we're using our solar scopes for viewing, you'll see more than just the moon starting to cross the sun. You'll see some sunspots as well, almost guaranteed. The sun isn't very quiet during solar maximum. So a bit of a tangent there, but I wanted to explain that image and where it came from. So it's a fairly recent video of the sun. Actually, if you want to go back on our Facebook feed too, we were streaming out some solar views this week. So that's another option as well. So here's another model of the sun. So right now we have these two models that we can use to start our eclipse talk. And even before we really, I guess, focus on these two solar objects, let's just look around the room at some light sources and some shadows. Like if you look below you, you'll see multiple shadows being cast. Your legs might be casting multiple shadows, the chairs. And of course, that's all coming from the lights above you. Wherever there's a light source, it will cast a shadow. And you can try and cast your own shadow too, just by if you lay your hand out flat in front of you and you put it above one of the lights, you can start blocking out light. And your hand is then casting a shadow onto your face. And doing that, you've made an eclipse. It's as easy as that. The principles of the eclipse are there. For a solar eclipse, it's just the moon blocking out the sun. Things are lined up just right so that the sun will block out, the moon will block out sunlight. So you could even try that up here with our image of the sun, or over here with this other 5-foot wide model of the sun to make your own eclipse. So that's all it is. You're playing with lights and shadows. We'll talk about this in more detail with the types of eclipses, because there is a variety there, but at least that sets the scene It's just a play of light and shadow. So our types of eclipses. Starting with our solar eclipses, because that's our main focus for today. Solar eclipses are an alignment of Earth, Sun, and Moon, such that you can end up with these three options here. You can have a total, which is the best solar eclipse. If you can see to get to totality on April 8th, I promise you it's going to be hundreds of times better than the partial eclipse that will happen in most other locations. So total eclipse, fantastic. The total eclipse is when the moon is completely blocking the surface of the sun. So you don't get any of the surface you're seeing here on our model, to the point that with no bright, even edge-on surface, you're getting the solar corona, which is only visible, especially the inner corona, during these total solar eclipses. And I'll have a little video that I'll play through and show you the process of partial to totality in just a moment, but that's the total eclipse. Then there's these annular eclipses. This is still here, the sun and the moon. But notice the moon is just too small, really, to fully block out the surface of the sun. And I'll have a video that explains that in more detail as well, but there are cases where the moon will be smaller in the sky, smaller than the sun, and it won't fully block it out. There'll be other times where it's just the right size or even bigger than the sun in the sky, and that's where we get total eclipse. And then we have these partial eclipses, which is always where a total eclipse will start. Majority of when we get to April 8th, if you go to a location that will have total eclipse, like 90% of the time it will be a partial eclipse, even more than that. So just a couple minutes, 2 to 4 minutes for this eclipse event, will you have totality, this one here. So those are the types of eclipses we can see. October 14th is when there was a ring of fire. That's what this one is often referred to as, an annular or ring of fire eclipse. So that won't happen. This event won't happen during April 8th. So this is going to be a video that takes you through an eclipse, partial eclipse to totality. Did you have a question?
You said there was an annular in October. Where was that visible?
So actually, I guess I don't have that map. I have the second half. Oh, but we have it over here that we got from NASA Goddard when we visited. You can see on this map, this has both the October 14th and the April 8th eclipse. And this is the path through the U.S. of the October 14th. So it's interesting. It's almost like the two sides of East Coast and West Coast of the U.S. where these eclipses are coming from. And they both, if you're lucky enough to live there, you got to experience the Ring of Fire and you'll get to see the total eclipse. So that was the path for October 14th. And we'll see that map blown up in size for just the April 8th coming up. Okay, so yeah, this video will take us through from partial eclipse to totality back to partial. A little bit of a simulation of the day of the eclipse. So notice that's the moon passing in front of the sun. It's moving because, of course, the moon's in orbit around Earth. So that's what's driving that motion. And you get that really nice crescent sun, and then eventually, boom, you get totality. This is a time lapse, so it's even those 2 to 4 minutes, those go by really quickly in this footage. And then the partial eclipse continues on. And once the event ends, if it is sunny that day, which we really hope so, it will be, did it stop? Uh-oh. What happened?
Try hitting escape. Yeah.
My computer's not responding either. That's weird. Bear with me a sec. My mouse isn't working. Let me try this. I'm going to unplug for a second. I'm worried my computer might need a reboot because it's just not responding. Let me try. Okay, bear with me a second here.
So you saw the image of the eclipse as it came. It got really bright right before totality. That's called Baily's beads with a diamond ring. It's where the last bit of sunlight is going through the mountains on the moon, and it actually looks like a diamond ring, or they call it Baily's beads. And it happens again when it goes out of the eclipse. And that's your warning to put your glasses back on, because then it's going to be too bright to look at. Anybody have any questions in the meantime? Yes.
Where did you get glass?
It's funny you should mention that. We have ordered, so you can buy glasses on the internet and stuff, but some of them, especially we found out last time, weren't really safe. So we have safe ones that are guaranteed with the right standard. We sell them here for $5 each or 5 for 20. Okay, and we'll be selling right at the store out here. They have a little bit of the Kopernik logo, and they have instructions, some data and stuff on the side, so we kind of learn from it. Yeah. Yeah, and they're not just good for the eclipse, they're good. Last Saturday I was here with some Boy Scouts, and they were literally looking at the sunspot with just those solar glasses on. You know, looks pretty big. Yes.
Well, when the sun has those sun flares, that will cause
Okay.
it to be
I got it here. Do you got it there?
See,
Okay, good.
And when they're facing the Earth and they hit the outer gases in our atmosphere, they cause the aurora borealis, or the ones in Australia down south, Australia borealis. Yep, exactly. Sorry,
Okay.
Dave.
Well, that was perfect. Thank you, Art. Thanks for bearing with me. I think we're hopefully this works. I don't know why it's skipping like that, but we'll see what happens here. Like Art was mentioning, I'm going to try and show you that like single frame of Baily's beads, or like the diamond ring effect, like right there. Oh, let me put it on pause. Okay, so yeah, you see going into totality, right, if you see that effect, glasses come off. Glasses are, as soon as that goes away, your glasses can come off, because with the glasses on, you won't see totality at all of it. That corona around the moon there is too dim. And yeah, like right here, backing it up, there we go. On the other side, once you see that same effect, time for glasses to go back on to observe the partial eclipse again. So those are your nice indicators if you go to travel to totality. Okay, and just briefly touching on lunar eclipses, there won't be a lunar eclipse on April 8th at all, because this is the exact opposite of solar eclipse. Solar eclipse is during a new moon. So that means that you have Earth and Sun, and the moon's in between them. Lunar eclipses are your full moon, will only happen during a full moon, and that's where the Earth is between the Sun and Moon. So on the opposite side of the moon's orbit.
Now, I'm not sure if this is accurate, but I seem to have read recently in North America, there's going to be a lunar eclipse on the 25th, 24th of this month. I don't know if that's true or not, at least in our area. But
I do remember seeing something about at least a penumbral, maybe lunar eclipse.
it may not be right in our area. That's why it might not.
Yeah, we could, when we go and explore one of the resources I have for you, maybe we could look at that and see. The one thing, if it is a penumbral, it's really not going to be super interesting to look at. If it was observable here, if it's a deep enough penumbral, you will see some shadowing on the moon, but in most cases they aren't as impressive as a partial lunar eclipse, or ideally total, which is a good segue here. Up here we have on the left the total lunar eclipse, and on right the partial. Just like with solar eclipses, you start with your partial. As the moon enters the Earth's shadow, in this case, the shadow grows across it more and more until you get to totality. What is nice about total lunar eclipses, they last longer because the Earth's shadow is bigger. That ends up giving you more time, especially if you're fighting clouds at all. You should have more opportunity to see a total eclipse. One note I'll say about the color on total eclipses is that's coming from Earth's atmosphere. Even though the moon is completely in Earth's umbra or shadow at this point, there is still indirect sunlight coming around through our atmosphere, and that does get projected onto the moon. My favorite quote for this is, it's like every sunset, it's as if every sunset and sunrise is happening on the moon all at once. Because that's the exact same principle of where that color comes from, just like you see pink skies or redder skies during sunset and sunrise. That's just a quick look at lunar eclipses. So now we're going to model the eclipse in a couple different ways. We got to think about the size of these objects and the distance of them. And I'll also have some models that show you the effect of the eclipse and in the position of these objects. Okay, so to start off, we have this image of Earth and Moon. And of course, our real planet Earth is way, way bigger than this image up here, right? We're standing on. Here's the US up here. And when we model things, we're just shrinking them way down to size so that we can understand and compare them to other objects like the moon. So we have our planet, we have our moon, and this is a comparison, a direct comparison of them at the same scale. And one way that you can look at this is that you could fit about 4 moons across the diameter of Earth. So moon is 4 times smaller than our planet. Another reference point, if you've ever done east to west coast travel and how long that's taken, the moon diameter is about the same as the width of the United States from east coast to west coast. So you could just map the US right on the moon here, and it would be roughly the same size. Okay, so that gives you a sense of scale for these objects. But if we're going to bring the sun into the mix, I can't fit the sun on this screen based on the model we have going right now. This also wouldn't work. This is also too small to map out with this model. So what we're going to switch over to is instead now we'll focus on this model here. And yes, I do have one. If this is our model of the sun, that's 5 feet wide. We shrunk the sun down to 5 feet. If we shrink Earth and Moon at the same rate, Earth would be about the size of a dime. Meaning you could fit about 100 dimes across the sun here. So about 100 dimes fit across the 100 Earths, fit across the diameter of the sun. Way more dimes would fit across the diameter of the sun. Another way to think about this, and this one I also have a moon model for, if you're familiar with Lego, there's this Lego plate piece that has the 4 studs. That's the size of Earth. Just a single Lego stud is the size of the moon. And that, again, you could fit 100 across this 5-foot wide sun, or you could fit 400 of these across this 5-foot wide sun. So the sun is way bigger than our Earth and moon, right? And that may start the question in your head of, okay, if that's the case, why is it that the sun and the moon are the same size in our skies, or approximately, right? We talked about there's some variance there, but for the most part, they're about the same size. In fact, they're about the size of your pinky nail, held out at arm's length. That'd be about the size of both the moon and sun from the ground. So here's another view of the sun, and this time with a comparison of Earth and the moon. This little speck here is Earth, and this even tinier speck is the moon. So again, 100 Earths across the sun, or 400 moons across the sun. And then that brings us to the idea of distance, which is really what is controlling the apparent size of these objects from observing from home. And for Earth and Moon, that's 250,000 miles away from each other. Both for the Apollo missions and the upcoming Artemis missions, it did take and will take astronauts about 3 days to get to the moon with even modern spacecraft. So it gives you a sense of scale there as well. The sun is 93 million miles away. So much, much further away. And to put this in even more perspective, the reason the moon ends up being the same size in our sky as the sun is because it's 400 times smaller, but also 400 times closer to us than the sun is. So that's why they end up being about the same. Okay, now I have a few videos to narrow down our eclipse model even further. This first one is going to show you the total eclipse as in how it happens based on the shadows of the moon and its orbit around Earth. So we talked about it's only happening during new moons. So you can see we're not going to see any surface of the moon, no surface, illuminated surface. And you can see the way the shadow is projected. There's a much smaller umbra, a dark shadow, that maps out totality. And then the penumbra is where you would see the partial eclipse. And now we're bringing this down more to a 1-to-1 scale for Earth and Moon. And you can see just how tiny not only are the objects, but also the shadow of the moon itself. Okay, so there's one eclipse model that shows you how the shadows work. All right, going to our next one. This is going to help us answer the question now of the annular or ring of fire eclipse versus total eclipse, which has to do with the distance of the moon to Earth. That's the only variable at work there that drives that. So again, watching the moon orbit around Earth, you see that it is, like most orbits, in fact, all orbits have some sort of elliptical nature. So there is going to be a perigee when it's closest to Earth and an apogee. And as Earth goes around the sun, this will change when we get perigee and apogee for the moon during its phases. And that gives us the chance to either see a total eclipse or it'll be too small during apogee to make a ring of fire in that case. So right here, it's pointing to the moon at apogee. if the sun was over here, the moon would be too small in the sky for us to actually see a total eclipse. We would just get that ring of fire if things lined up right. Which brings us to a kind of final question with our models here, which is why don't we have a solar eclipse every month? You saw in each of those videos, they were simulating as if an eclipse was happening every month. But that's because you were only looking at it from one angle. If we look at the orbits in the same plane, or roughly the same plane, you'll realize that the moon's orbit is a little bit different from the Earth's orbit. It comes in at an angle, so this video helps show that. If it actually plays. Why do we keep having this problem? Again? It's responding, but it's not happy. I apologize. I don't know what's going on.
When this happens to me, I call Jenny and she fixes it.
Well, maybe I'll just pull that video up on the, just off to the side, like through the media player rather than in the presentation, because that seems to be where it's getting hung up. That one actually didn't really require a whole reboot. That's good. Okay. Okay, I'll get this out. Okay, so here's that video that I wanted to show you. So we're looking at it from the same angle as before now. But now we're going to rotate down the view down so that we're looking through the Earth's plane. And now you notice that the Earth's orbit is at an angle. It's tilted above the plane of Earth. And because of that, only on occasion will you get everything lined up just right for eclipses, both lunar and total. So you won't have a total or even lunar eclipse during every full moon, and you won't have a solar eclipse during every new moon. All right, let's jump back to this one and not click on the video because it doesn't like that tonight. All right, so now we can focus in on the solar eclipse here at Kopernik, or just in our general area, and looking beyond as well. Oh, did we? Okay. Actually, can I borrow the mouse for a sec? Just so our people on the live stream can enjoy the show too. That one did not. Oh, yes, it did. Okay, good. All right, so that worked for them. You on the live stream should have it back up now. This is that map minus the October 14th eclipse. So we're just seeing the April 8th path of totality here. And you notice how narrow the path of totality is. So that's the moon's umbra, that narrow shadow passing across the US there. It will start, if you look at the times here, it is in Central Time down here and then Eastern Time up here. It starts in Mexico and will move across up into the northeast US and then into Canada. So that's the path over time. At any instance, though, as the eclipse goes on, I can model this for you too. If this is our sun, the projector up here, and then, of course, this map of the US is Earth, I can assign this foam ball to be the moon. And if I line things up, we'll go this way so we can shrink it down to the right size. This is what the shadow would look like when it first starts, right? It's just going to be a circular shadow, and that shadow moves across this path based on the moon's orbit and the Earth's rotation, moving up and along, and that's as high as I can go. But that's a really simple model just using this setup right here, and you can see the shadow will be circular because the moon's circular, or the moon's spherical. This map also shows you these gray lines, which section out the partial eclipse for locations. So it's not terribly visible, these little numbers here, but they show you the percentage values for each of those gray lines. So up in here, this line that's nearest to us, so here's Binghamton. If we take this line, it says 95%. We're even past that. So I can tell you that our eclipse will be about 97% partial eclipse. Still not good enough for totality. We'll only have a partial eclipse, and which means at no point will the sun be safe for direct observation with your eye. But we are really close. Okay, so, and then of course down further, you come down to lower percentages here. If we just take a random place in Florida, like maybe near Miami, that is a 40% partial eclipse. So even all the way south in the US of us, like, they still get to see something. 40% eclipse is still a very observable and can be an enjoyable event, especially when you play with a lot of the resources that make observing a solar eclipse fun. All right. Another model we can use is this NASA Eyes on the Solar System. For this, I got to back out here and jump into this one. So you can find NASA Eyes on the Solar System just by searching it through Google, or you can type in eyes.nasa.gov. And it often does work with smartphones. It can be the input can be a little bit tricky sometimes, but usually it does work pretty well. And they do have a section right off the top here that says featured stories and events. And these are more scripted interactions with Eyes on the Solar System. You can also just look at the solar system in 3D and go to different objects and explore. You can also see things like the Parker Solar Probe, OSIRIS-APEX, major missions that NASA has out there, and you can learn about them that way. But for our use case here, we're just going to click on the 2024 Total Solar Eclipse. And it's going to play out this scripted event that you can watch the shadow of the moon pass across Earth, where it starts, where it ends. You can also see the different levels of eclipse. This little tiny shadow, just like we saw on that map of the US, that's the path of totality, or mapping out the path of totality. So it's about to start passing through Mexico. You can see the clock down here, around 2 p.m. Path of totality comes up, heading into the northeastern US. You can notice the percentage points here too, tell you what the partial eclipse phase, it only goes to 50%, but you can see the edges of the penumbral shadow. And then, yep, it passes over, and you can see that shadow goes shooting back out into space. Okay, so that's one way that you can view this. You can also do interactions like viewing it behind the moon. So almost from the moon's perspective here, you can see the shadows that are cast. And it does the same thing. You're just viewing it at scale as well. You can view Earth and the moon together. And of course, at any time during one of these, you can rotate and look at a different perspective. And then if you want to see everything, the alignment of the sun, Earth, and moon, you can try that as well. And I think it's really helpful that those shadows are mapped out so you can see exactly what's going on. So that's one model that you can play around with. It's not the best way for sure to figure out and narrow down exactly where you're going to be on the day of the eclipse and what the timing looks like for you. But it's a good option for gaining better understanding of what's going on. Okay, and then I think the next slide I had was, yes, this one. So we won't even go back into that. We'll just go right to timeanddate.com because this is another good resource for you. If you're trying to search around to different locations and pick an observation spot, timeanddate.com does a great job of showing you what the eclipse will look like, what times each phase plays out in, and it's just a great platform to explore these events. So here is the April 8th eclipse for roughly our location. We have it set up for Vestal Center, which is right nearby. And we just did that by searching. I'll show you another example for totality in just a moment. But when you scroll down, you can actually scrub through the eclipse event. So you can, this is just before the eclipse, and then you can get to your start of partial, moving through to our maximum eclipse, and that's so upsetting that we only have that sliver. And then we move on to the end of the eclipse. And then it gives you the timeline just below that, so it tells you partial eclipse for Kopernik here starts at 2:08 p.m. Maximum eclipse occurs at 3:23 p.m. and the partial eclipse will end at 4:34 p.m. So you can see just about over the course of 2.5 hours, this eclipse event plays out. So lots of opportunity to observe the partial eclipse here. What you will see during this maximum eclipse here, you will get that sliver. You'll see that in your eclipse glasses. Or as we'll see later, if you use pinhole viewers or pinhole projection, you would get that shaping, that very thin crescent as a projection. There are other things to watch out for during this maximum eclipse, though. It is deep enough that you will notice changes in the sky's brightness. You'll notice things are off. There'll still be daylight, for sure. The skies will still be blue. But it's like turning down you have a dimmer switch at home for lights. That's kind of like what's going on here. So the skies will darken a little. What's also really neat is that shadows will be very crisp. So again, look at the shadows around the room right now. And notice how fuzzy they are. They are fuzzy because these lights above you, and this, if you get a shadow cast from the screen's light here, it's spread out over a wide area, meaning that light's coming from multiple different angles, which is a recipe for very fuzzy shadows. With this maximum eclipse for our area, it almost becomes a point source of light. And when you have a point source of any light, that's going to give your shadows a very crisp edge. And that's something to watch for too. That'll look very different from a regular day on the sun because When the sun is just out like this, even though it look fairly small in the sky, there's still light coming from it at multiple different angles, leading to a little fuzzy edge to your shadows. Not the case for that maximum eclipse. So that's a neat thing to watch for too. It's also possible that there might be some small changes to the way life is reacting around us, but we'll get more into that with totality because it definitely happens there. Okay, so that's partial eclipse at Kopernik. Now let's take a look at a nearby total eclipse location, which would be Syracuse. Syracuse is will be one of the most accessible totality locations for us, where we are in southern tier, New York. So let's jump into that. And you see when I search, it just gives me eclipses in Syracuse, New York in general. And yes, it says March 25th, penumbral lunar eclipse. That one might even be a deeper penumbral, so you may just catch some shadowing on the moon during that event. I'm kind of curious what the timing is for it, since I mentioned it earlier.
It's going to be around midnight on the 24th and go into.
Oh, okay. Yeah, it looks like 12:53 a.m. is when it begins for us, or near us. 3:12 a.m. is maximum, and 5:32 a.m. So it's early morning event. But if you wanted to try for that, you can see how close it gets to the umbra. There's only this amount of distance to get to where you would actually notice some deep shadowing on the moon, but the moon will certainly be dimmed in brightness during that March 25th event. So it is neat that they are so near each other. Okay, back here though, this is the one we want. So here's Syracuse, and we'll start things off before the eclipse. We'll look at the times as well. Partial eclipse begins at 2:09 p.m. So right there. And then it goes to the start of totality at 3:23 p.m. Right there. Your maximum totality occurs just tens of seconds later. And then totality ends at 3:24. So you have about a minute and a half, looks like, for where this location was set up. I guess for just Syracuse generally. The nice thing, though, is if we look at this map too, the way Syracuse is kind of positioned is if you go more northwest, even into northwestern Syracuse, you would get deeper into the path of totality, which the closer you get to the center of this path, you bump up the time for totality. So it can be anywhere from that 2 to 4 minute timeline. So places that are more center line, you can see the eclipse ends just around the same time as us. So running through that 2.5 hour mark for Syracuse. But if you were to choose somewhere like Rochester, you see it tells you get almost 3 minutes 40 seconds of totality up in this section. So yeah, the closer you can get to that center line, the better. Just depends on how much time you really want with totality. In the end, a minute can make a big difference, especially if it's partly cloudy that day. So keep that in mind if you are going to do some traveling. And you can look at, you can find maps here. This one might even, yeah, this one's good. So if we zoom in, it gives you that center line. You see Watertown is right near it. It does go into Lake Ontario, Rochester is near it, and it does pass right through Buffalo as well. So you have lots of options. And if you're willing and able to get up bright and early that day for travel, and you're up to date on the weather forecast, that may give you the option to bounce somewhere that might have better conditions. if the weather's very variable that day. So that's an option too. But keep in mind, we haven't quite gotten to safety yet. We will in just a moment, but the roads will be crowded that day, before and after the eclipse. So if you are going to do travel that morning, get on the road early, and if your plan is to try and head back home, be prepared to be on the 81 or wherever you end up for a while. It will take some time to get back home. Okay, so that's the eclipse path. So timeanddate.com is great. I am getting a little low on time here. I don't want this to go too overboard, but I will briefly show you my third resource, which is Stellarium. If you've attended a Kopernik program in the past, then you may be very familiar with Stellarium. I bring it up almost every time I present, at least. And this is your at-home planetarium, so that you can explore. I'll bring up the downloaded version here. You can explore the skies however way you want. You just click and drag to, as if you're moving your head, right, looking around the sky. So you can see, like some of you observed earlier, Jupiter was out. You can click on Jupiter, press the space bar, and zoom in. It's a really nice tool. But you can also use it for eclipse viewing. And it's just another way that you can see exactly what it will look like wherever your chosen location is. So if I go to April 8th, and we're past the eclipse time at this point, because the time stayed the same. It's about 9:03 p.m. We got to back up the clock to around 2 p.m. This is set up for our location. So if we zoom in, you see the new moon right there. And if we advance the clock, you can watch the eclipse play out all the way to maximum for our area. And it would simulate totality as well if we set it up for a total eclipse location. So that's available at stellarium.org. You can also search it on the App Store. It's one of the Starfinder applications that are there. All right, we did that. We did Eclipse and Stellarium. Okay. Now as we start to wind down the show, we really have to focus on solar eclipse safety. Again, this is a last but certainly not least case. So first thing, as Art talked about earlier, for one thing, we do have eclipse glasses at Kopernik that are safety certified. We actually sourced our glasses from the same place NASA does for the ones that they provide for their events. And what you're looking for with eclipse glasses is the ISO certification. So that is a safety certification that's specifically for the filters themselves that make up the lenses of the glasses. They're designed to absorb or reflect all harmful rays of UV and infrared radiation that come from the sun, and and block out the intense visible light as well, so that you can look at the sun with these on as long as you'd like. And there's something else I wanted to talk about with these. I forgot. Well, I do have some examples. So let me show you those. So here's a regular pair. These are of the NASA branded ones. And I'll come around and show you that, yep, there's the ISO certification. And they do give you instructions on the glasses as well. You can see the filters too, and when I hold these filters up to my eyes, I can't see anything through those lenses at all. It's only a bright and intense light that's going to make it through. So you could totally practice with these on a nice sunny day. Maybe if there's a sunspot like I mentioned earlier, you might see that if it's big enough. But that's a regular pair of eclipse glasses. Now I have a damaged pair of eclipse glasses to show you, to start a conversation on what not to use them for. These are designed for your eyes, right? You hook them up just like regular glasses. Ideally, you want to try and fit them around if you're wearing glasses, like regular glasses, you want them in front. You could potentially put them behind too. The magnification at work with regular glasses, it's not high enough to focus in and melt these lenses, but just keep that in mind. It can be very tricky to fit them around, so that's why I mentioned that. What you would not want to do is hold up a pair of binoculars in front of these with them on, because those optics are high enough magnification that they'll do this. I'll come around and show you. So same glasses, same lenses. A pair of binoculars was held up to these and melted right through them. I'll show you over here. So that's a case of what not to do. Same thing, not just with binoculars, but a telescope as well. You would not want to just put these around your eyes and look through an unfiltered telescope either. You may only have one hole, but you also may only have one working eye after that. So that's another big danger. So yeah, eclipse glasses, very useful for the partial eclipse phase. As we talked about earlier too, you don't want these on during totality. Once you're getting towards the end of that partial eclipse and the start of totality, you're looking for those Bailey beads or diamond ring effect. Once that passes, these come off so that you can enjoy totality to its full effect. If you're here in Vestal or in our general area where it's only partial, these have to stay on whenever you're observing the eclipse. And also a good rule to follow with using them, if this is our sun that we're observing here, back to the sun, put your glasses on, turn around, observe the sun for as long as you want. Once you're done, back to the sun again, glasses off. And that minimizes the possibility of just kind of instinctively just wanting to watch the event with your eyes. That's what we're trying to avoid, because the eclipses, especially once you get to that maximum partial eclipse for our area, it is going to be dim enough where it might almost seem like it's safe. But your eyes won't tell you that they're being damaged until later. So we're just constantly trying to, it's such an interesting event that you just want to make sure you're protected at all times during it, and you don't have that instinct to just look with your eyes. So yes, the eclipse glasses are available at our store afterwards if you would like to pick up a pair or a few pairs. So those are there for you. Also, I'll just briefly mention that they also give you nice guidelines on the phases of the solar eclipse, when it's safe to take them off, which you see it's only during totality, and when you should have them on, which is for regular solar observing and partial solar eclipse. And then on this side, it does give you a little graphic of the alignment of Earth, Moon, and Sun, so, and the shadows at work that make that happen.
Jenny designed those glasses for us.
Yes. So those are available there if you'd like them. So the other point here too, you want to make sure you're protected you're protecting your skin from the sun as well. Don't neglect your skin when you're focused so much on your eyes, because you'll be out there for a long time. That 2.5 hour partial eclipse for our area, it'll be about 2.5 hours everywhere, whether you get totality or not. So that's a long time to be out under the bright sun, or not so bright eventually. Make sure you're protecting your skin too. For the same reason, it's the ultraviolet rays that cause sunburn, right? That's what we're trying to protect our eyes from and our skin. Okay, here's another nice way to observe the eclipse. And we will have these available during our Family Fridays. So if you'd like some, you're welcome to come check out that activity-based event. But this is this card here. And you see there's some instructions telling you how these pinholes work. It says using a hole puncher, make holes in the square below, rectangle below. It can be a pattern or design. With your back to the sun, use the pinhole viewer to shine the sunlight on the ground or a piece of paper. So the diagram shows you the eclipse event, sun and moon, and how you should use your pinhole viewer. I have one with a hole in it. You can see there. And if that's my sun, all you do is you punch. You can do something very simple, like just punching a single hole. Or you can add a design, because every single hole that you put into this, not just this card, but any piece of paper, it will show you the projection of the partial eclipse at that moment, just like you're seeing on this screen that they have here at the bottom. It's a little crescent mapping out the partial eclipse. So yes, the way that you would use that is I would face my back to the sun, because this really only works properly if you do that anyhow. So very safe way to observe. If you want, you can set a nice flat piece of paper down on the ground to act as a nice screen, and then you line up the view so that you can project an image of the sun. The principles of a pinhole projector or pinhole camera as well, you may have heard it that way, they're pretty neat. The way the optics work are, instead of refraction, it uses diffraction. So the light rays are just coming through and bouncing off these inner walls, and they focus down, just like a telescope or binoculars or my glasses. It's the same basic idea at work, but just a different physical phenomena. So that's really powerful. And I don't think I have them in this show, but maybe if I jump over to, because Sasha, who's operating our live stream during the annular eclipse, she was out in Texas, in McKinney, Texas, enjoying that event and also live streaming then too, which you can go back on our channel and watch. But she took some pictures of a bunch of different items. So I'll just bring this up, this one slide here. So maybe you can tell what some of them are. Up on the upper left, there is a colander. So a colander has a bunch of holes in it, right? And this was during a point of, was this maximum eclipse, Sasha?
This is actually from NASA. The next slide is.
Oh, the next slide is yours. Okay, let me go to the next one. There we go. And was this during maximum, roughly? Okay. So this was during maximum, during that October 14th eclipse. And you see that here's a cheese grater. All these pinholes here, mapping out the current state of the eclipse. You could also just do something as simple as crossing your fingers together and making tiny holes there and projecting the eclipse on the ground. On the right side there, I believe those are some tree leaves. And on a regular day, it would have the little light coming through in between the leaves would take on a circular shape, because that's the shape of the sun in the sky. But during an eclipse, you get all these little crescents. So these are really neat things to watch out for as well. As you look at what's happening around you, or you bring some tools with you, things like a Ritz cracker, little holes in a Ritz cracker, that would work too. Oh, the Ritz cracker? Oh yeah, yeah. So you could do things like that. Okay, let's go back here. So yeah, lots of ways that we got to focus on being safe during the eclipse event, and lots of tools that we can use for observing. Up at Kopernik, we have filters for our telescopes that will be in operation during the partial eclipse, and we also have some neat projection telescopes. Our heliostat in the physics lab next door is awesome because it projects a 9-foot diameter sun that you get to watch the eclipse play out on. or we also have some smaller scopes that do solar projection too. So lots of safe ways to view it at Kopernik as well. Okay, and last thing, this is going to be very brief, is just some basics on solar eclipse photography, because this could be a whole second presentation. So just touching on this a little bit. Some general rules to follow when you want to get a picture of the eclipse, whether it be partial or total. Don't neglect your eyes to get a good photo. So your phone, like if you've taken a landscape photo in the past, and you've taken an image of the sun happened to be in it, or maybe you take a shot of a sunset or sunrise, those quick shots from a smartphone, they're not going to affect the sensor much at all. You're not going to damage your phone by taking those shots. What you are doing, though, is you can potentially damage your eyes through that process if you're trying to get the perfect shot, lining things up, and you're staring at the sun in that time, right? That's another use case for these. They can be handy for helping you frame up shots without staring at the sun for any use case with photography. So you don't want to neglect your eyes to try and get the right photo. Solar filters might be necessary for your device, be it a smartphone or just a more advanced mirrorless camera, CCD cameras, and so forth. Actually, I should emphasize that. Certainly, if you have a large lens, a telephoto lens on a mirrorless camera, you need a solar filter on that if you're going to be observing over the long term. Smartphones are it's a little bit different for them because the lens itself is just so tiny. This is effectively a pinhole in its own right. So you really don't want to just hang your smartphone on the sun over a long period of time, like during that 2.5 hour window. And in the end, too, you're not going to get a good shot that way. One way that you can get a good shot is, did I put on these ones? Yes. By taking your eclipse glasses and putting them in front of the lens. And that's going to knock down the brightness of the sun to the point that you can catch the shape of totality, or well, not of totality, of the partial eclipse. With totality, you can take as many photos as you want, with the exception of that last rule there. Don't forget to enjoy it with your eyes. If you're going to take pictures of totality especially, where your window is very narrow, set your camera up beforehand. If you can, set it up to automatically take photos at the right settings. And just let it do its thing. It's not a case where you really want to be doing too much of this. Because it's such a rare opportunity, especially with one so accessible to us. So yeah, we want to keep that in mind as well. Because you should be able to set up a nice, like if you can get your camera fitted on a tripod, you can even tape. If you have, actually I have another example of solar filters. These little bar style, they're the same material as eclipse glasses. These can work well for smartphone lenses too, and they work the same. You could use them in front of your eyes, or you could tape them to your phone. Anything like that would work well. And during the partial eclipse, because you have a lot of time to work with, you can have some fun. This was during the partial solar eclipse, I think it was June 10th or 11th in 2021. And it was an early morning solar eclipse, so you can see the sun was rising. What was really neat about that too is it was near maximum for this location in Syracuse when I took this picture. And so as the sun rose, it was very ethereal. Like it was very weird how the sunlight was rising. But yeah, with one neat thing, this was just taken on a smartphone. my smartphone was not just hanging on the shot for one thing. And so it was just a quick photo. And you can actually count a whole bunch of eclipses in this image, not just this one here, the primary, but also this one down here in the viewfinder. Of course, we were running a live stream there too, so there's those ones there. But there's also this little one right here. If you can look carefully, there's a little flare, a little lens flare coming from the smartphone's camera, and it's just this little crescent. So those are all little things to watch out for during the event. You might find that there's all these eclipses happening, all these projections happening everywhere. And then here's a time-lapse video of the eclipse, and I hope it works. If not, it's the end of our show. And it might be the end of our show. This was the last slide, so I'm not too concerned about it. But just to, I guess, roughly explain it, as the sun was rising, the way the lens was set up, it cast a similar lens flare, and it ended up looking so weird the way this hangs up. And it tries to do things, but it's not working. But it kind of looks like there's two suns for a time, and they're moving in different directions. So very Star Wars, if you enjoy Star Wars. So yeah, that does wrap up our first eclipse presentation. We'll have a few more leading up to the eclipse as we march to the eclipse. Eclipse glasses are available in the gift shop if you'd like to pick those up tonight. And also, we could run, for anyone that would like, we could probably run one planetarium show as well if you would like to see the eclipse inside the dome. So that gives you a nice preview there too. That's an option. Other than that, the telescopes, is there an update on that at all, or Mark?
No, but if it's not clear to look at something out in the scopes, we'll give a tour of the dome itself.
Okay, great. So some end of program options for you. Definitely venture out to the scopes to see if the skies are clear enough. And otherwise, thank you so much for joining me at our Friday night program tonight. Thank you. And Family Friday is next week. So if you want to do activities, that'll be then.